Alright, so for taking the wheels off, on some machines it's as easy as these pin clips here. So you flip the ring back and then the clip will come out. Now this one comes out really nice and easy because I put a little bit of penetrating oil on this ahead of time, as well as it looks like somebody previously applied anti-seize to the axle shaft. So if I pull on the wheel, yeah, this one slides off really nice. But you can still see that we have some rust forming on the axle and inside of the wheel here, and so we can see that there's some rust there. So we're going to want to clean this up a little bit. I'm just going to wipe it down. It looks like it's not too pitted. Actually, that looks like a plastic sleeve that's there. So that's to prevent the wheel from seizing on. So what we'll do is we'll reapply some either grease or lubricant, or I've become partial to fluid film for this type of an application. We'll put something on there that's going to be a barrier. Fluid film should be safe for the plastic, and we'll put some sort of barrier there that will prevent the wheel from rusting into place, so that if the drivetrain ever needs to be serviced, these axles can be slid out. And with the wheel off, we'll give the bearing on the outside here a small spritz. Doesn't need a lot. We'll get that. Some machines you might have exposed bearings on the outside versus the inside, and while the wheel's off you would want to grease those. Some machines also will have grease fittings on the outside of these axles, or they might have a grease fitting on the wheel on the inside. So we want to be looking for those and greasing those. And so what I'll do for this particular wheel here is I'm going to just shoot some fluid film right to the side, inside the hole here for the wheel, and then slide it on. And wipe up my excess here. Okay. And we'll get that all over the pin. Now sometimes these shafts will have multiple holes, so we need to make sure that we find the proper one and get that back into the depth. So there's a hole on the outside part here, but this pin came from the inner hole, so we need to find that. There it is. Flip that over. And then there, that one should be easy to pull back off next winter if it needs to be. Now let me show you the other side where this pin has been replaced with a bolt and some of the issues that can result from that. So here's the other side. The pin has been replaced with a bolt, and the threads of the bolt have gotten rather rusty, along with this is a lock nut and not just a standard nut. So I've pre-applied some rust penetrant, seeing that it was rusty and hoping that it increases my chances of it coming off. So I'm going to need to loosen the bolt, but before I do want to take a wire brush and see if I can clean out those threads and get some of the rust off of the threads, because that will make spinning the bolt out a little bit easier. It's kind of hard to get in here because it's recessed into the wheel a little bit. The bolt itself turns in the hole, and it does turn kind of tough, okay, but as that rust piles up in the nut, this actually gets harder and harder. Chances are, if I get this out, I'm going to be replacing it with a new bolt and a new nut for the customer. I'm actually going to use an electric ratchet to see if I can speed this up and make life easier for myself. It is turning, but not easily. There we go. So if we're lucky, it will come out, but you can see it's rather rusty. Let's see if the wheel comes off. So if the wheel doesn't come off, we're going to have to try to pull out on the wheel, push in on the axle, but we want to be careful about banging things around that we don't cause any damage to the bearings, the shaft, or the rest of the drivetrain by banging on the axle to get it out. We also got to make sure we don't mushroom this axle. So, you know, they usually don't give us a whole lot to grab onto for the wheel here for pulling on it. We don't really want to pry too much on the backside there, so we'll work at the axle to get it off. If I can't get it off all that easily, I probably won't get overly concerned about it because the other side does come off in the event that the drivetrain would need to be serviced. I think the axles for these machines are available and not overly expensive, that if I have to cut the axle, press it out, and then purchase a new axle to repair the drivetrain, that shouldn't be too bad. But given the age of the rest of the machine here, this is probably the last drivetrain, any repairs or anything for this machine. Chances are the next time this needs service, it's going to get replaced. So we'll see if I can get it off. If I can get it off, I'll come back with the camera and I'll show you how I got it off. Otherwise, we're going to keep moving forward with things. And I'll set you up and I'll show you one more thing to check before we put this down on the ground and move forward. All right, so one other thing to observe or note before we go ahead and set this down onto its wheels again is to take a look at the scraper blade here. You can see this one is mounted underneath the housing, and these are the bolts that hold it on. And then these are your skid shoes here, and well, the one that would have been here. We want to take a look at it and see how it's wearing. If we're going to need to make an adjustment, we would want to apply some rust penetrant and try to loosen these bolts before we set it down, so that'll make it easier to actually do the adjustment here. You can see that the scraper blade has worn rather unevenly. Okay, it's not uncommon for this to happen. In giving it a quick walk around when it was dropped off, I did check with the customer to see if they wanted to purchase and have new skid shoes installed, and they declined, indicating that after this tune-up it's not likely to get any more work. So we will probably do our best to make sure that everything's adjusted and it's still scraping the concrete flat. But sometimes this can happen if you have a tire that keeps going flat, or if you have one of your axle bearings that's worn and so the machine itself is leaning from one side to the other. So when it gets this way, you know, we can either replace the scraper blade, or we can try to, some of these, you can flip them around the other way and have a fresh edge on the back side if it hasn't been used, because you can see there's more sticking out here than there is this side. But when it gets to this point here, you can see the bolts are half ground off. Chances are I'm going to end up having to snap the bolts off with an impact and then replace the bolts if I want to adjust the scraper blade. So just something to note. I could try putting some penetrating oil and hope for the best. But before I go ahead and mess with these, I'll probably put it down and see how close to the ground it is to see how much adjustment, if any, needs to be made. And same thing for the shoe here. Either the shoes were not adjusted evenly, or the tires were low, or an axle bearing was worn out, caused this thing to lean to the side and wear unevenly. At this point now, we're just concerned about making sure that the scraper blade can contact the ground as evenly as possible. We want to kind of take note of that and do anything that we can while it's up in the air like this. Next thing to do will be to fill the tires, make sure the tires are properly inflated. After the drivetrain is done and our inspection's done, but before we set it down, the next thing to do would be to check and adjust our tire inflation pressure. Make sure our tires are properly inflated and holding air. When we do this, oftentimes the manufacturer might specify the recommended inflation pressure in the manual, which we oftentimes don't have. I've found that normally filling them up to about 75% of their maximum inflation pressure works pretty well. You can see here this this tire has a maximum inflation of 20 psi, which is pretty common. And so that means that we're going to fill that up to about 15 psi. And so we're going to use the tire inflator here to do that. It's got a nice digital readout, plus we can add or subtract air as needed. And it doesn't take much. This one had about nothing in it. And it usually doesn't take too much, but it's also room temperature. When we take this outside, it's going to cool off and the pressure is going to drop a little bit more to something closer to 10 to 12 psi, which is probably about where we really want it. So we'll do that to both tires, make sure they're as even as possible. And if we have one that seems to be going flat or low, like I said earlier, that can cause our scraper blades to wear unevenly. So in that case, we'd want to take it off, dunk tank it, and see if we can locate the point of leakage and then deal with it either by inner tubing it, cleaning up the bead and bead sealing it, or replacing it. Move on to adjusting the scraper blade and the skid shoes. It's going to sit flat anymore. So the scraper blade being reversible is going to need to be reversed. And so I got started on grinding off the burrs from the nuts, not seen in the video here, but the nuts had been ground down halfway to the point where the socket would only grip the first three, and then the last two, the 6-point socket, couldn't grip, so I had to go get a turbo socket designed for removing damaged nuts, and that worked fantastically. Basically, I just put the impact on there, and I added a little heat to see if that would help them spin off, but if not, if I kept hitting with the impact long enough, I was fortunate enough that it's just snapped the bolts right off, and so it was a matter of punching the bolts out of the holes, which went relatively easily to get it off. Pretty much know going into this that you're going to end up replacing most or all the hardware during the process. So the scraper blade is off, and that flips and still lines up and everything nicely. And if you're adjusting the scraper blade, you need to adjust the skid shoes too, so those had to come off next. Tried again heating those. Those looked in a lot better shape than the scraper blade, but they all pretty much just snapped. The heat probably just helped them snap a little bit quicker. And then of course the nuts get stuck in the socket, so you got to keep knocking them out of the socket. Now that all the old hardware is out, you put some new nuts in, you'll notice that I leave them all loose and I assemble them all, so that way that I can set it down, check for fitment, and do the adjustment while everything is still a little bit loose, and then I come back and tighten them up. Notice that when I tighten down the scraper blade, I start in the center and I work my way outwards to the edges, and it's just snug enough to hold it in place that it's not going to shift a lot. And then I make sure that's flat on the ground. I check the feet, make sure they're flat on the ground. I'll snug up the feet, and then I'll take a wrench and I'll snug up that outside bolt just enough to kind of hold the blade in place, so that when I tip it back up I can do the final tightening. And then I left a dirt pile on the floor because I decided that's an easy way to check contact with the ground with the scraper blade and see how well the scraper blade can basically sweep the floor. And if it can sweep the floor real good, then it should clear the snow just the same. So we'll tighten up all the scraper blade bolts. We'll double check, make sure that everything scrapes and fits and works and is clean and even and tight. And then don't forget to clean up your mess when you're done. Now with our snowblower on the ground, we're going to want to go ahead and check the auger condition. If it's a metal auger, we want to make sure that it hasn't come loose, or any of the welds have rusted out, or it's bent, or the sides of the housing are bent in far enough that they're going to hit the edges of the auger. And we want to make sure that the shear bolts that hold the auger blades to the shaft are actual shear bolts and haven't been replaced with pins or hardened bolts that ought not to be there. And some augers will have grease fittings like these ones here and here. So what we're going to want to do is put some grease into there. The idea behind this is to help prevent the augers from rusting and seizing to the shaft. So that way the shear bolts can do their job. So I'm going to just pump this till we see new grease come out. You can see it coming out right there. See the red? Okay, that's the new grease coming out. So I got that one. I can't get to the other one yet, so I'm going to have to rotate the auger over. And to do that, I'm going to come over to the engine, and with the auger drive engaged, I'm going to hold it down, and I'm going to slowly rotate the engine. And then check and see if that's rotated my grease fitting. So now that I can see the other one here, I'll hook this on. And we'll give this some pumps until we see some fresh grease come out. And then we have to come back and wipe up the excess grease. So we'll do that. But before I go wiping up the excess grease, we've got some bearings here. We're going to give these some shots of white lithium. Okay. We'll clean up the excess in a moment. Last thing we want to do is inspect the auger gearbox housing here. We're going to check for leaks, check for any vertical looseness or play, end play, back and forth. Make sure that that impeller in the back there is good and it doesn't look like there's any evidence of it scraping or moving around inside of there. These are either filled with a grease or an oil. And so to check them, you can either use an open-end wrench, or this is a 8-point socket for the 3/8 pipe plug here. I can use that. I'm going to take this out. And so this is where we need to look up to see whether the manufacturer supplied an oil or a low temperature grease. If it's a grease, we'll want to squirt some grease in there. Currently out of low temperature grease, but I've got some on order. So we would squirt some in there, and then we'd put the plug in, and we'd work it around. If it was oil, we would fill it with oil until it starts running back up out of the hole. So hopefully that'll show up soon so we can fill that for this customer. And then we just snug it up. Okay. And that'll do it for the front auger housing. You can also see the scraper blade along the bottom and the shoes in the housing. You can see that the housing is relatively straight yet, and it's not bent in to the point where the auger is going to make contact. That can sometimes happen on some of the older machines that have been around a while and been run into curbs and edges of driveways, etc. So we'll come back in here. We'll wipe up our excess best we can. All right, and then we'll move on to the next phase, which is greasing applying some white lithium grease to any of the moving pivot points and the chute of the snowblower. Okay, so for lubricating the chute of the snowblower, if it's a plastic one, I usually leave them alone. If it's got a metal base like this one here, I usually like to get the straw in here for the white lithium grease in a couple of different spots. Let's see if I can move this so you can see better. Okay. So I'll stick it right into the corner see how it moves around, and you can see that gap. So that way it gets in between the two metal surfaces and prevents this from rusting or freezing in position. And then we like to come around and just give a little spritz to all the moving parts of our machine. So we'll do that. We could even do the chain again a little bit here in the chain case, intermittently. We'll come around to all the shift levers. Any part that pivots or moves on a regular basis, and that's not plastic, we're going to give a little shot of white lithium to, and then we'll roll it around back and forth. Make sure it gets distributed. If we need to, we can reapply it. And that'll keep that from rusting tight or reduce the chances that the water that gets in between the two doesn't freeze. And then now you gotta bang the chute to dislodge it so that you can adjust the direction that your snow throws. Okay, so now that we've got the auger service done, we can go ahead and check our worksheet here. The metal auger condition is okay. We've greased the Zerk fittings. We don't have a rubber auger, so that would be NA. Those are for usually the smaller ones, the single stage ones. And then we've wiped and cleaned the white lithium grease on the chute. And now we're going to go around and check our clutch cables to see if they need any adjustments. Usually those are in pretty good shape. And basically for that, we just push down on the clutch lever. Come up here. We'll push down on the clutch lever, and then we'll take a look at our belt. And we want to check and make sure that we've got sufficient belt tension and the spring is holding tight up against the belt. And then it should retract. This one's still missing its spring, that causes this to retract. So it's a little bit sticky. Hopefully once we get the spring, that'll be resolved. And then this one will be for our traction drive system. So I'll hold that one down. Make sure that one tightened up. And you can see that's pulling tight like it should be. And then when I push down on the clutch lever, that should be engaging my wheels. So if I try to move the machine, okay, it should drag on the machine, because that way the drive plate is forced into the friction disc. And so that clutch cable is good. If we did need to make adjustments to our cables on this particular machine, this threaded sleeve at the end of the cable is where we would make that adjustment. We would need to remove this cover and loosen that lock nut, and then we can tighten or loosen and adjust the length of our cable so that when we pull on it, the cable goes tight, and we can tell that there's tension on the spring down here underneath it. Okay, and then when I let go, they should go slack so that it's not dragging on the clutch or the friction disc or wanting to self-engage. And then this is the one that goes extra slack. You can see it's really loose because this is the one that's missing the spring yet. So once we get that spring installed, this should tighten up a little bit but not be too tight and operate better. One of the customer complaints is because that spring's not there, is that over time this will rattle right off. It's not supposed to be quite that loose. Okay, so the spring is meant to take up the slack here so that that doesn't come quite that loose. There it goes. Getting close to the end here, we're going to verify that our scraper blade is on the ground and it's flat and straight the best we can get it, and it's making the most amount of contact with the ground. Previously we noted that ours was worn, so we would check worn, but we flipped it around, so now it's okay. The guide feet are, one is missing pretty much and the other one's pretty well worn, so we'll do that there. Our initial height, well, it ranged from about 1/8 of an inch off the ground to 0 inches off the ground, and now it's all 0. So we'll set it at 0 inches up off the ground. Some customers might have a gravel driveway or a very uneven driveway and may need or request that their scraper blade be raised up off the ground a little bit so that it doesn't catch so much or pick up and throw the gravel. So occasionally we might need an 1/8, quarter, or larger shim block underneath the scraper blade while we're making adjustments, but not this time. Okay, next thing to do is to finish installing the spark plug, get that torqued down, and give it a final check over, and have your instructor give it a final check over and put all the covers on. You may have noticed that I left all the bolts loose till I got them all in and situated and started, as well as verified that my holes for making adjustments to the carburetor lined up. Don't forget to put your choke knob back on. And then once you got everything set, we can go ahead, go around and start tightening. And make sure you don't forget any of them. Now we torque our spark plug to specification, in this case 150 to 180 inch-pounds. There we go. And with all covers installed in your final checkpoint, it's time to test fire it and make sure that everything works as it should.